Greetings, dear friends, fellow programmers, and those aspiring to be. Today, we will be talking about a way to optimize the performance of your ASP.NET Core application by utilizing Singleton Services. I'm sure you were wondering how can you improve the performance of your application and to do it effortlessly. If you did, Singleton Services might be the answer. And today we will be learning everything about them so you would be able to make informed decisions when would be the best time to utilize them and when you should definitely avoid them. First, let us talk about the Singleton service lifetimes because we need to understand how they work, but I guess from the name itself you can figure out that basically it means that this service is going to be instantiated once and then reused across the entire lifespan of our application. So no new instances of the service will be created over the time, of course, unless you restart the server or redeploy the application. In those cases, a new instance would be created, of course. Now, let us move on to the benefits that Singleton Services are going to provide us with. So, if we know that only a single instance of these services is ever going to be instantiated, we know that we will not waste precious resources on creating new instances over and over again. Basically, by reducing the instantiation process, we are improving the performance of our application and allowing it to scale and perform better. Of course, that applies only to scenarios where the functional benefits of Singleton Services are okay with the way your application works. So, for example, if you utilize Singleton Lifetime for your DB Context service, you, my friend, would be in a lot of trouble because your DB Context is going to be instantiated once, and then whenever we introduce some changes, it's going to blow up because the changes that were created from some other place are not going to be propagated in the service itself because we are reusing the same instance of it. Which is why, for DB context, we want to use scoped, in most cases, or transient lifetime. Now, let us get back to our Singleton discussion. How it works is, as we already know, we have a single instance that we are propagating across our application and reusing it. It's basically like having a single coffee maker machine in the entire office so that every single employee is using that same coffee maker to make their cup of coffee. So why would anyone want to use Singleton service? I mean, not everybody wants to use the same machine as everyone else. Some people want to feel special. Well, Singleton services are awesome for scenarios where you're completely fine to reuse the same instance. I'm talking about caching scenarios or configuration reading scenarios and things of those sorts. Basically, when you want to have a stateful service that is going to remember the state, you will be golden when using Singleton service. If, of course, the values are not supposed to be updated occasionally. And of course, there are certain best practices that you definitely want to follow while utilizing Singleton services. So let us discuss what they are. You did not see that coming. We are back in our Visual Studio, and here I have prepared for you a very simple and straightforward service that I'm going to use to show you how Singleton works. As you can see here, we have a very simple service that is supposed to mimic us reading the configuration file. So we have a simple dictionary where the key and value are both strings. So we have key values that are app title and version and their respective values. And we have a single method that is going to be called getSettings. And we provide a key to it, which is going to be used to fetch the value from the dictionary and return it as a result. And also, just to make sure that we are clear that no new instances of this service were created in the process, I have introduced request ID field, which is going to be populated only when a new instance of this service was created. So when we enter the constructor, we will populate request ID with a new GUID value, so we will know every time when we instantiate a new instance of this service, we will have a different GUID. So, if we are using Singleton, we should always have the same GUID. Let us register this service, and as you can see right here in our program CS file, I have registered it as a Singleton, and we need nothing else to add here. We can jump right to our controller, and there we can provide the information we need. We have a private field, which is going to be an instance of this service. We populate the value for this field by injecting it through constructor, and then we just fetch the configuration for app title and return the value we received. So now, when I run the application, let's see what we get. And as you can see, we got the value for our app's title from the configuration dictionary. And also we received a GUID for the request ID. So now when I refresh the page, we should get the same exact GUID no matter how many times I refresh the page. So trust me, I'm refreshing it. Let me open the network tab and let me show you. I'm really refreshing the page, but the request ID is always the same. That is because we are using Singleton Service. Now, here comes a tricky part. As you already are familiar, we are reusing the same instance of our service across the entire application. So, potentially, because we want to be using asynchronous programming because it's the best thing to do, we are opening ourselves to update the service from different threads at the same time. And this, my friend, can cause some serious issues. So, let us introduce a different parts to our application, where I will create a counter which is just going to count when we access the service and get value endpoint. So let me update the service. So now it has a counter which is going to be incremented every time we access get settings method. I'm talking about something like this. We have created a private field called access count, and we're just incrementing the value whenever we call get settings. I have also created a get access count method, which is just going to expose the value of this counter. So if we were running an application from multiple threads and calling this get settings method, we would end up incrementing our counter from different threads, which can cause complete disarray in its value, because it can cause inconsistency in our data. So the only thing we needed to do was to introduce another private field called lock, and then to lock our access counter within that lock. And now we are thread safe. We do not need to do anything else here. It is going to work perfectly across multiple threads. Of course, I'm aware that we did not cover locks in our previous videos, so if you're interested in learning more about this topic, please feel free to let me know in the comment section below in this video. I will gladly film a series dedicated to those advanced features where we can cover locking and thread safety. So yeah, just let me know. And for the end, I have prepared a very special example for you with another advanced feature that is at our disposal. So, as you probably were able to guess, because of the fact that Singleton Services are remembering the state of our application, they're remembering the state of the service, when we try to instantiate it, it is going to be usually more expensive than instantiating transient or scoped services. So we do not want to do that and instantiate the service when we do not need to use it. And in the current implementation, the new instance of our service is going to be instantiated either way, whether we use it or not. So we want to prevent that from happening. And that is exactly why we will introduce a concept of a lazy initialization of our service. So to do that, you can take a look at the code and the updated service, and you can see that we are using another field created, which is called instance, and it is of type lazy, which wraps our service. And then we just instantiate the value with a new configuration service, which is basically going to mean when I ask for this instance of a service, you will then and only then instantiate a new instance of it if we do not already have it. So it will not do it before we are actually using it. And this is also one of the topics I will definitely consider covering in future, because it's very beneficial, but still more advanced. And finally, now that we have mastered how Singleton services work and why they're so great, I think it is a great moment to discuss real-life scenarios when using them is definitely, in most cases at least, is going to be beneficial for you. And we are going to getting started by covering the point you are already probably familiar with. I'm talking about configurations, because Singleton services are great whenever you are working with configuration files which are not updated. Also, they are great for logging, because when you create a new logger instance, you usually do not care about the requests or transient lifetimes. You just want to have a logger service which is going to log everything that is happening in your application, so you do not need a new instance for it. Of course, if you want to have a request-based logger which is going to log request-related stuff, then you might want to use scoped services. But in general, when you want a general logger, you will be golden by utilizing Singleton. It is also great for caching, because when you cache stuff, you want to have it at your disposal throughout the entire application, and you do not want to update it over time. You just add new stuff into the service, and then you can access it for the specified amount of time. So why would you instantiate a new service for that? You would usually not. You do not need that, so a Singleton instance is going to be perfect for those scenarios. Now, this one is a bit more project specific, but if you have an application which allows some kind of customization of features that are going to be enabled in the application, then utilizing Singleton services is great, because you want to be consistent across the entirety of your application. You do not want to have request-related consistency. You want to be consistent across the entirety of your application and its lifespan. Basically, when you want to lock or enable or disable certain parts of your application, Singleton services are the way to go. Singleton services also do wonders with event bus and messaging queues. So in those cases, you should definitely consider using Singleton lifetimes. And finally, you can use them for telemetry. When you want to track behaviors and track what is happening across your application, you can use Singleton lifetime services. They will do an amazing job for you. And that is it. We have just covered some of the common real-life scenarios when you want to use Singleton lifetimes. And now, in conclusion, we can say that Singleton lifetimes, when combined with scoped and transient, allow us to be very accurate, very explicit about the lifetimes of our services, and that way we can adjust the performance and optimize it so that our application behaves exactly as we want it to. So I hope you have enjoyed this video and found it useful, and if you did, I would like to kindly invite you to subscribe to the channel and turn on the notifications, because that will allow me to reach to more people interested in programming. And finally, until the next video, I would like to thank you for watching and wish you an amazing day. Happy coding!